Okay, so this is going to be a full Unit 8 AP Calculus review. First, we're going to start with something pretty simple, average values. There's a pretty, quick and easy formula. Let's say you have an interval A and B. To find the average value of something over A and B, you'd have 1 over B minus A times derivative A to B, and you have f of x dx. And now when it comes to units, with these ones specifically, the units stay the same as they were beforehand. So if you have miles per hour and you're trying to find the average value of that, it would still stay in miles per hour. Now let's go over an example, for example, or let's go over an example. A function f is defined by f of x is equal to x squared plus x minus 2 sine parentheses 2x plus 5. What is the average value of f on the interval -4 to 1 round to the nearest thousandth? So we're going to put 1 over 1 plus 4. It would be 1 minus -4, but we can simplify that to 1 plus 4. And you multiply that by the derivative of from -4 to 1, x squared plus x minus 2 sine 2x plus 5, okay? And you just put this into your calculator. The thing about Unit 8 is that it's basically all done through your Calc, which is short for calculator. But, you'll find it relatively easy to just plug in numbers and play. But that also means that there's no way of knowing you got something wrong unless it's really egregiously wrong, as you'll see in a second, because it's all being done through the calculator. Now let's talk about definite integrals in context, specifically when it comes to particles, position, velocity, and acceleration using, integrals. So let's say you start with velocity. You just have velocity, and you're trying to find the displacement of something. That means you have your car, and you have the miles per hour of said car throughout the whole journey, and you're trying to find out what is the total distance from point A to point B, okay? Just how long, if it was a straight line, would it be to, get through that? And that would be, for the interval of A to B, it would be from an antiderivative of A to B, and that's v of t. Okay, that one's simple. However, when it comes to distance, you're not going to get a straight path when it comes to driving around. So there's going to be parts where you have to take a left turn and a roundabout, and there's all this other stuff that's it's not the most efficient. So when you're looking for total distance driven, you're going to have the same thing, except you want to really hone in on this key part right here. These are absolute value symbols, okay? So you have to put that into your calculator, absolute value. Now, if you don't know how to access absolute value, let me just do it on my calculator here. First, let's just put in an integral. We're never going to actually fill it out, but here it is right here. You're going to go into your middle part right here. You're going to press math. You're going to go to numbers, and you're going to press abs. Abs for absolute value, not abdominal muscles. As you can see right here, there's those two little lines right here, and that will show that everything is positive. Now, let's talk about final position. Let's say you want to know, you're at a starting point, and you want to know, okay, let me start it back. You start at 0, and you know that at time equals a, you were at 3. You're at 3 meters from the from 0. If you're trying to find out where your final position at B is, you're going to do s of a plus the derivative of b a velocity, okay? And as is just your placement. That's the thing that's given to you, so don't worry about that. The thing you want to worry about right here is just BA, and there's an addition symbol here, not subtraction. If f of a is known and f prime of x is the rate of change between a and b, you can use this to find f of b, which is f of a plus crowbar ba f prime x dx. Now let's talk about like the whole rigmarole with particles. If you have velocity, you can integrate it to get position, and with velocity, you can derive it to get acceleration. So, assuming that we know those and what symbols they have, we can learn a lot about said particle. For example, the particle is moving right if the velocity is bigger than 0, and it's moving left if it's less than 0. Velocity is increasing if acceleration is greater than 0, and velocity is decreasing if a is less than 0. The speed of the particle, and by that I mean like if it's speeding up or slowing down, the speed of the particle is increasing if velocity and acceleration have the same sign. It's either positive and positive, so it's going up and up and up really quickly this way, or both negative, which means it's going down and down and down left, like it's going left faster and faster. Speed of particle is decreasing if v and a have opposite signs, right? So it starts out fast, but it starts slowing down because of that acceleration. And it's getting closer and closer to 0. Its miles per hour are decreasing. Particles move away from the origin if x and or position and velocity have the same sign, and particles are moving toward the origin if position and velocity have opposite signs. That's just about everything you need to know for particles. However, there is no easy way of doing this. If you don't know these things, you're unfortunately going to be screwed. So I would really, break out those flashcards if you have them. Let's go over a context problem. I have some hidden solutions here, as you can see. A particle travels along the x-axis such that its velocity is given by v of t is equal to t to the power of 0.3 plus 4 cosine parentheses 2t. The position of the particle is x equals negative 5 when t equals 3.5. Determine the position, velocity, and acceleration at time t equals 4. So, to find position, we're going to have to use the final position thing I was just talking about. So we're looking for it at 4, and we were given 3.5. So I'm going to put 3.5 right here at the bottom of my crowbar and 4 at the top of my crowbar. I'm going to put the y value for 3.5 right here. Negative 5 plus, remember it's plus, crowbar, 4, 3.5, and then I just have my thing right there. And you would just simply do this one through your calculator. I've given it to you right here. This is it. So you could type that through your calculator right now as practice to see, do I know what I'm doing? Do I know how to put it into my calculator correctly, etc. Velocity at 4, that one's pretty simple. You just take your equation, you plug in 4, that's it. Acceleration of 4. You can also do this one with your calculator. I believe, yeah, I still have it in my y plot right here. This is actually going to be really helpful. Let's actually go back one. We're looking for a v of 4, and sure, you could just type it into your calculator, except replace all the t's with 4s. But you could also press trace, right? You can press 4, press enter, and you can find out that value right there, okay, of v at 4. And additionally, if you're looking for a of 4, which is the same thing as v prime of 4, not v4 prime, but v prime of 4, you can go into math, press 8, get your derivative, press dx, and then right here where it says x equals something, you press x equals 4. Now for the thing that we are deriving is this thing right here, and as you remember, I put that into y1. So what I want to do is I want to press alpha, and then trace, which will take me to F4. And this is going to open up a bunch of things right over here. Can you guys see that? Yep. These are all my y values that I had from way back when. So I'm going to press 1 so I can get my y1 from my graph. Okay. I'm going to press enter, and I'm going to get a number, right? It's just that simple. Now, what is the next, actually, we'll come back to that. If you haven't already, put these into your calculator, give it a shot. I'm going to wait right here so you can pause it. Okay, so if I lift them up, the values for the position is negative 3.59 and then a bunch of numbers. The velocity is 0.93 and a bunch of numbers. And my acceleration is negative 7.80 and then a bunch of numbers. So let's look at x and v. So because x is negative and v is positive, the particle must be moving towards the origin, right? And this makes sense because right here it's negative, it's behind the origin. But when it's right over here, it's moving right because v is positive, okay? So it's going that way. Now, acceleration also happens to be negative, and since v is positive, and so they have different signs, so that means that it's slowing down. That means it's getting to the origin, but it's slowly crawling there closer and closer. You know, like Sisyphus. Yeah, I guess the velocity is what did I say the stem thing was? Velocity is decreasing because a is less than 0. Yep. Now, what is the displacement from 5 to 8? Okay, this is the one where we don't have absolute value. So we're gonna have top of the part is crowbar. Top of the crowbar is 8. Bottom is 5. Put that in. Okay, do that into your calculator now. In fact, I think I'll join you so we can do this one together. You're gonna do math 9. At the bottom of your crowbar, you're gonna put 5. At the top, you're gonna put 8. And right there, you're gonna put y1 if you haven't already put it in, or you can just type it in. And then you're gonna do dx. You're gonna enter that in, and you're gonna get your value. And the value is 5.762, and then a bunch of numbers. Now, what is the distance from 2 to 6? Almost the exact same, okay? And this is where a lot of people get mixed up. It's almost the exact same, except for the fact that it is an absolute value, okay? So, let's do the same thing. Let's put it into our calculator. Math 9 from 2 to 6. Now I'm going to press math again, go to numbers, and go to abs, okay? So now I have my lines back. Then I'm going to type in y1 dx, and I'm going to enter it, okay? You know you're doing really well in math if it's taking forever for your calculator to calculate something. That means that you're doing really well, okay? Well, kind of gave away this one and this one. But yeah, the answer to that one would be 10.370 and then a bunch of numbers. So I hope that makes sense. If it doesn't, you know, just keep on practicing. That's the best thing I can say for this part, because at the end of the day, it is just basically trivia at this point, right? It is the math version of remembering a bunch of dates for your history test. Now let's talk about how to find area in between curves, okay? So usually when we're finding things with integrals, we are finding things below curves, okay? And sometimes we find it even above curves if we make it negative. However, we've never done it where it's between curves. And you'd think that the formula for it would be hard, but it's actually surprisingly not. All you have to do is you have to find your top and your bottom of your, I guess your curve, right? So right here, my g of x, which is something, something, something x, is above my f of x, which is something, something x squared. So it will be top minus bottom for the inside of my crowbar here. When we are integrating this, we want to find it, because we're looking for the area in between curves. The area in between curves ends right here and here, at w and at z. So you have to find w and z on your calculator. Okay, well, how would you do that? You go, plot your y values. In fact, I'm going to plot another one right here. Let's have it just be x. Right, these are my two values, and I press trace. Okay, boom, just like that. Then I press second calc, intersect, and I start scrolling, looking for a close enough intersection point. And once I do, I press enter. I press enter again. I press enter a third time. And once I do, I will get my W value first, right? My W value is 0.8021, etc. Okay? And for my next one, it's the same thing. Okay? You're scrolling down, except now to the opposite side. You're pressing enter, enter again, and enter one more time, okay? 3 times, that's the magic number. And right here I have 2.507. And then I just put this into my calculator. You're almost never going to be expected to do this without a calculator. So, lucky you in that regard. And yeah, that's just how you would find area in between curves. So let's talk about volumes with cross sections. So now that we found area in between curves, volumes with cross sections is asking us to find volume within curves. So I know that sounds scary, but I'm going to dumb it down a little bit. We're going to go way, way back. Every shape equation always has something that you are substituting in, right? A square. Side has another side is equal to side squared. Or a triangle, like an isosceles triangle, is side times another side divided by 2, because it's base times height over 2. So it would have 1/2 side squared. Or let's say we're looking for the area of a circle. Okay? It is side squared, because the side is my diameter, side squared, or side divided by 2, squared, and then I'm multiplying by pi, right? Because the circle equation is pi r squared. Well, in this one, I probably should have made it better. It's probably better as a semicircle. So I'm just going to erase that. Right, this is a semicircle. I'm going to divide it by 2, okay? Because your area is half of that. So this would be the S. So all these S's is truly your distance between your two lines. So let's take a look at this one right here. All you're doing is drawing a bunch of infinitely small lines. And you're making a circle or a square or a triangle or something like that within that, and you're basically making like a tunnel through this, and you're calculating the volume within that tunnel. And that sounds like a lot, but it's truly not, as long as we find S, okay? Let's take a look at this question right here. Let region R be the area enclosed by the function f of x. And f of x equals ln of x plus 1, and g of x is equal to 2x minus 1. If the region R is the base of a solid, such that the cross-section perpendicular to the x-axis is an isosceles triangle with a leg in the region R, find the volume of the solid. Okay, so isosceles triangle. Right here, 1/2 s squared. If we're looking for the distance, we're going to be using the same thing that we did with area of curves, right? You're doing top minus bottom, and then you're squaring that, and you're dividing it by 2. Okay, that's all you're doing, and then you're integrating that. So I have wy, zy, okay? And after I put that into my calculator, I will get 0.02. It's not too hard, but you should try doing this one yourself, okay? If you don't really understand it, start by plugging this in, okay? Find your points of intersection, plug this into your calculator, and try to see if you get a similar number. Now, this is a bit more confusing. As you can see, I have, shapes and symbols like a crazy person. The volume functions that we've seen prior to this, if you've been doing them on paper or on Delta Math, Khan Academy, etc., they've been popping out, right? So imagine those pop-out books that you read as a children or as a child, where they just like flip up and these things come out. It's like that, except they're 3D. So you're taking your 2D thing and it's popping out. However, when it comes to circles, not half circles for that matter, just circles, it is digging in as well as popping out. Okay? Let's take a look at this question right here. Let region R be the area enclosed by the function f of x is equal to x squared, the horizontal line y is equal to -2, and the vertical lines x is equal to 0 and x is equal to 4. Find the volume of the solid generated when the region R is revolved around the line y equals -2. So what it's saying is that these two parts right here, 0 and 4, are our boundaries. And we need to find what our R value is, or our radius. For some reason, when it comes to full circles, there is no need to divide by 2. So, lucky us in that regard. Our distance is just the radius. We square that. We multiply by pi, and you get your number. The distance, as always, is top minus bottom. So we have x squared minus -2, which is x squared plus 2. And that's our R. Now I'm going to square this R, and we're going to multiply by pi. Because pi is a constant, I just moved it out of the equation. And let's do it on the calculator. I know you can see it right here, but I just want to show to you how much easier it is when you do it with a calc, which is short for calculator. I'm just using slang, guys. 0, 4, x squared plus 2, goodness, plus 2, and then I totally forgot to square it, okay? This was a happy little accident, but, you have to be really vigilant when it comes to your equations in this unit specifically, because one small error like that, like forgetting to square, and your equation is wrong, okay? Because no matter what, it's going to be wrong. There's no way of, catching your mistake at that point. So now I fixed it. X squared plus 2 squared. I type that in. And as you can see, these are two different numbers. Okay? I'm going to give you a second to find out why I got two different numbers here. Okay. So the real reason why I didn't get the same number is because I didn't multiply by the pi on the outside. Right? I multiply by pi, boom. 961, 746, bunch of trailing numbers. So what I just showed you is the importance, the absolute necessity that you do not forget something so incredibly small. Because at the end of the day, 306, if I saw that on my paper, I'm like, yeah, sure, that's good enough. I would have completely missed the fact that, oh, that answer is incorrect. I forgot to multiply by pi. So you have to be extra vigilant when it comes to these kind of equations. Okay. So the volume of the objects have holes sometimes. So think of like a vase, okay? This one right here that we just did like a sphere almost, like a sphere. However, as we know, there are some things that are hollow a little bit. The volume of the objects have holes sometimes, and these can be calculated by doing the total volume minus the empty space. So R is equal to the total volume, and little r is equal to empty space. Capital R is always the farthest one away from the axis of rotation, and the little r is the one that is closest. Okay, so your R value is going to be your function farthest away from the axis of rotation minus the axis of rotation. And I know that's a bit confusing because I don't really have an example right now. Same thing goes for little r, and same thing goes for little r. You have your function closest to the axis of rotation, and you are subtracting it by the bottom function, which is your axis of rotation. So it'd be top function minus axis of rotation, and you're going to square that. So that's r squared minus little r squared, and little r squared is your bottom function, quote unquote, or not even your function closest to the axis of rotation minus your bottom function, okay? And that's also going to be squared. So it's going to be big R minus little r squared. and then you're going to derive this from w to z, which is your points of intersection, and then you're going to multiply by pi. The way I have it written out right here, it's super nebulous, unfortunately, and that is because there's no example, but hopefully this will make it easier. So, find the volume of the solid obtained by rotating the region bounded by x is equal to negative 2 plus y squared, and x is equal to y, about the line x is equal to negative 3. So I chose this equation specifically for two reasons. One, because it's a washer equation, which is what we were just talking about right there with the vases, but also it's over the y-axis, okay, not your x-axis. And when it comes to your y-axis equations, you want to have, you know how with your functions from beforehand, it would always be y equals da-da-da-da-da? With these ones, it's x equals da-da-da-da-da. And in your da-da-da-da-da, there will be y. So thankfully, I've done it right here for you. X minus 2y plus y, or x minus 2 plus y squared, and x is equal to y. And it's being rotated about the line negative 3. So as you can see, this thing right here, when it comes to the enclosed region, okay, I'm going to shade that in. This enclosed region, y, or this linear equation that we have right here, is the farthest away from your axis of rotation. This is our axis of rotation, right? X is equal to negative 3. Can you guys see that line? Yeah. So because this is the farthest away, this is going to be our big R. But before we do that, it has to be subtracted by the bottom. So we're going to do y minus negative 3, which is y plus 3. We have to do the same thing with our little r. So our little r is going to be negative 2 plus y squared. Oh, goodness. I think I got this one wrong. See, this is how important your little signs can be. This is negative 3. This is supposed to be positive 3. Right? So instead, this would be negative 2 plus 3. This will be instead plus 1. So y squared plus 1. Okay, so this means I've certainly screwed up my equation quite a bit, but we are going to work through it. And in fact, this is probably going to give you a better example of how to go through a problem like this. So we're going to use the formula we had at the beginning of pi times the integral of from z to w, r squared minus little r squared. All right, so we're going to put our r squared right here, y plus 3 squared minus y squared plus 1 squared, right? And we're going to look for our points of intersection. I've already done it here. It's 1 to 2, all right? It doesn't look like it, but I promise you it is. Oh, yeah, no, it actually kind of does look like it. I think it's actually negative. Wow. You know what? Just in case, we're going to do this on a calculator. On y equals. I'm going to start with. Oh, shit. Okay, it's a little bit harder to graph this one out because, you know, we have our x value here, and we have to go back to y being on its own. But I was given this. I was given these two in my delta math, so which is where I get most of my equations. So I think these are okay. I'm just gonna roll with it. Anyway. Oh, I just thought of a way to find out. X is equal to x, so I can substitute this into the equation to find out where my points of intersection are. Y is equal to negative 2 plus y squared. So I'm going to move over this to the other side. So we're going to have y squared minus y minus 2 is equal to 0. I have y minus 2, y plus 1 is equal to 0. And then we're going to find out that y is equal to 2 and negative 1. So, yeah, I was right about my mistake being that this is supposed to be a negative 1. but that is okay. Second quit. Let's put this into our calculator. In fact, let's start with putting the pi at the front. Pi right there. Math 9. -1 to 2. Parenthesis. X, because it's kind of hard to do y. I'm just going to do x. X plus 3 squared minus x squared minus 1 parenthesis squared. Okay? This should give us our true answer to the equation. Type that in. Yep. That is completely different from whatever I had here. And as you can see, I rolled with it. I'm like, yeah, that looks right enough. You know, this is probably correct. In fact, let me see if it would have been the same if I did this. Yeah, see, even if I did it with 1, I made a mistake so far in the beginning that I would have just got it wrong. But, you know, this is truly me, explaining to you guys how important it is to catch your mistakes and not me just fucking up on camera. There we go. 2, 1, 2. Because this is a lot of calculator work, you're going to find that it is best to never round anything. Do not round anything, just in case, until the very end. And when you do, round to 3 places. But with all that being said, with all the mistakes that were made, that is the end of the Unit 8 review. The most complicated part is probably the context. That's what it was for me, right? All that trivia that I was talking about at the very beginning. But this whole volume finding thing is relatively easy once you get the hang of it. Right, if your teacher assigned it, there's going to be delta maths on it, and you can find practice problems on the web. It's not too hard. But yeah, I wish you best of luck. And yeah.